Okay, let's get into it. Today we're doing a deep dive on a really serious piece of gear.
A real powerhouse.
It's the DVIGear DVI-7348. It's a 12G-SDI fiber optic extender. And its whole mission really is to create this super reliable end-to-end fiber workflow for high-stakes broadcast jobs.
Right, for the most critical environments.
Exactly.
Yeah.
So its main job is extending 12G-SDI signals uncompressed. When you're in a situation like a huge stadium, or you have a remote camera miles away, why is something like this so essential?
It's all about reliability and consolidation. This is a match transmitter and receiver set.
A match set.
Yeah, and it's built for these huge distances, really high data rates, and crucially, it supports everything from old school SD-SDI all the way up to 12G. So you're basically future-proof for, high frame rate 4K.
You just mentioned data rates. The spec sheet says it handles up to 11.88 gigabits per second. Why is that specific number so important?
Because that is the exact bandwidth you need for a pure, uncompressed 4K video signal at 60 frames a second.
Anything less and you're in trouble.
You're in trouble. You start getting compression, you get artifacts. This system delivers that critical speed over a really significant distance. It uses just one single strand of single-mode fiber.
And how far are we talking?
Up to 6.2 miles. That's about 10 kilometers.
Wow. Over a single tiny fiber cable. That just seems wild.
It is, and the efficiency is just staggering. Think about setup time, cost. You're replacing a huge bundle of copper cables with one thin fiber.
And there's an even longer option, isn't there?
There is, yeah. They offer an extended version that pushes it out to 25 miles.
So 40 kilometers.
40 kilometers. But it's also smart on site. The transmitter has an SDI input and a buffered loop through.
Ah, so the camera operator can have a local monitor.
Exactly. And the receiver at the other end has two buffered SDI outputs, so you get redundancy or maybe multiple feeds for the control room.
Okay, so that covers the video. But what about control? I mean, for a real remote setup, you need more than just the picture.
This is where it gets really interesting. The control signals are actually multiplexed right onto that same optical link.
No extra cables.
None. Both units have dedicated connections for RS-485 and tally light control.
So RS-485, that lets the control room change camera settings remotely, right? Like focus, zoom on a PTZ camera.
Precisely. And the tally light control, well, that's what tells the operator they're live on air. So you get full video, full control, all down one fiber.
And it looks like it's built like a tank. It says here, a rugged, die-cast metal enclosure, locking BNC connectors.
Absolutely. It has to be. But that ruggedness is paired with the biggest benefit of fiber: signal integrity.
You mean avoiding interference?
Exactly. Think of a long copper cable in a stadium like a giant antenna. It picks up all the RFI and EMI from lights, comms, everything.
Right.
Fiber is just, it's light. It's completely immune to all that electrical noise. Your signal is perfectly clean.
And speaking of extreme environments, I saw the operational temperature range. It's kind of insane. -40 up to 185 degrees Fahrenheit.
Yeah, it's built to survive just about anywhere. And one more thing on the signal. Don't forget the audio.
Oh, right. How much audio can it handle?
It can embed up to 64 channels of 48 kilohertz 24-bit audio right into that 12G SDI signal.
64 channels. So you don't need a separate audio snake or anything like that?
You don't. It's all in there.
So to sum it up for you, the DVI-7348 is this incredibly robust long-distance solution. It consolidates your high-res video, your camera control, and a massive amount of audio onto one single fiber strand. It just solves so many logistical headaches.
It really does. And maybe here's a final thought to leave you with.
Go for it.
When you think about the sheer complexity of that signal pristine video, controlled data, 64 audio channels, all sent reliably for miles over one tiny strand of glass, how does that fundamentally change the math for planning a live event or how you'd set up remote studios? That's the real game changer here.